we're going to learn how to use part of an array. So the purpose is this. The array, when you declare an array, you can only declare it for a fixed size. You cannot declare an array with variable size, unfortunately. So, but when we are writing the program, if it is a professional program, that program should work for anybody who wants to use it. So therefore, it should work for any size array. That's how it should be. But unfortunately, we cannot make the array variable size. So we have to find a way around that. So here is what we can do. For example, if I'm writing a program that calculates average grade and number of A's, number of B's in the class and all those things, in the grade-related program, if I'm writing one, then I should make sure it works for any size class. But then, how do I do that? I have to declare an array of size, fixed size in the program. So we have to find a solution, and the solution is this. Just think about the largest size a class can be and set your array to be that size. So everybody using this program is not going to have that many data. So what they have to do is they're going to have to use part of the array. The elements, the data they have will occupy part of the array, and so your program has to be designed to keep track of how many data are being stored in the array and only process that many data. The array is going to be larger than the actual data. So you need to control all that. So you're going to learn how to do that. So I'm going to use a simple example to illustrate how to do this. And the example is array for calculating grades, average grade and maximum grade and all that. So here is the problem. Write program that obtains grades of unknown number of students from the user, stores them in an array, and determines the largest grade. We are only finding largest grade, but you can find the average grade and count how many A's are there, count how many B's are there. All those things can be done. So I simplify the problem to have only finding maximum grade. All right, so let's go to the maximum grade function first. The function is called findMax, and it's going to receive an array in the name array, and then the size of it. The size would be the part of the array that's filled. So if the array is going to be maybe size 100, but if there are only 25 elements in there, then that 25 will be received here. So this program, this function will work with only 25 elements. So here is how you find max, the same technique. You copy array 0, the very first element, into the max value. And J starts at 1 and goes up to less than length. So if there are 25 elements, J goes up to 24 from 1 to 24, because array 0 has been already copied into max value. So I have to start at array 1. So the J starts at 1 and goes up to length of the array that's filled in with data. For each one, the array J is compared to max value. If array J is bigger than max value, then max value equal to array J. That's all you need to do. And so basically we are comparing each element of the array. The J is changing here. So each element of the array J is compared to max. If it is bigger, then it's copied into max, and then J increases, and the loop goes with the new J. So for all the different J's, all the different subscripts, the array J is compared to max value. And if it is bigger, it replaces max value. And with that strategy, when the loop ends, max value has the maximum. So when the loop ends, I can return the max value. This function will return the largest number found in that array. That's all this function does. Okay, so we can call this function to find the maximum. Now let's go back to the main program. And since I have the function at the bottom, I have prototype at the top. And inside the function, inside the main program, I'm declaring the array grade as size 100 because, I want to allow any size class, but I figured that the size of a class cannot be more than 100. So 100 is the maximum it can be. So I put the size of the array as 100. Variable largest will hold the largest grade. Now count is the variable that's going to keep the count of how many data went into the array. And you'll see how to count it. I don't have to manually count it. By using the subscript value, I can figure out what the count is. All right, so I'm getting the first grade before the array begins. I set the I to 0 here. Oops. All right, I set the I to 0, and now I'm asking for the grade. And the grade I'm getting will be stored in grade 0. I is 0 right now. So storing in grade 0, and then comparing that grade 0 against -1. Sentinel control loop. Now, why do I need Sentinel control loop? Because I don't know how many data will be coming in. That's when you need to use Sentinel. So Sentinel control loop means you have to get the first grade before the loop begins. In this case, the first grade I'm getting is stored in grade 0. And then I'm saying if that grade is not -1, and also I have to make sure I is under 99, because I have to be within the limit of the size of the array. Just in case somebody is going to use this program for more than 100 data, our program cannot work for them. So I have to make sure I'm not going to store more than 100 data here. That's why I have to add this condition. I has to be less than 99. So if these conditions are true, then I will increase to next number, and then I ask for the next grade and store it in grade I. So each grade I is then compared to -1. Only if it is not -1, I ask for another grade. I increase the I and ask for another grade. So when it is -1, the loop ends. But the -1 is actually getting stored. See, I'm storing every number I'm getting. And at the end, -1 will be stored. And when the grade I is equal to -1, the loop will end. So when the loop ends, I already have stored all the data. Let me use this to illustrate for a example numbers, set of example numbers. So I'm going to make up some grade numbers. Let's say I have grades 85, 92, 78. And user will enter these and then a -1. So there are 3 grades. And if I store 3 grades, how do I know there are exactly 3 grades? How do I count them? Do I need a counter? We don't really need a counter. I'm going to explain why the I itself, the subscript I itself, can be used to count. Here's the grade array. Grade array is large, 100, size 100, and we're going to store only a few elements. So here's 0, subscript 0. Right now, let's start this program with those data. I is 0, so I'm asking the user to enter the grade, and that's going to go into grade 0. The user is going to enter 85. 85 is the first number here. So the 85 goes into grade 0 right there. Okay, now I becomes 1. Grade 0 is 85, which is not -1. So loop proceeds, increases I to 1, and grade 1 is getting the next number, 92. So 92 goes into grade 1, subscript 1. And then it goes up here and compares the grade 1, which is 92. And it's not -1. And also I less than 99 is true. So I increases to 2 and ask for the next grade. And that grade goes into grade 2, which is 78, goes into grade 2. And then the I becomes 3. The grade 3 is compared to -1. It's not -1. I becomes 3 and asking for the next grade. And now user is going to enter -1. So the -1 is getting stored in grade 3 in the third element. Now when we come back to the top, grade 3 equal to -1 is true now. So grade 3 not equal to -1 is false. So the loop ends now. So when the loop ends, you have already stored 3 numbers. And what is the I value? What is the value of I now, right now, when the loop ends? Anybody?
4.
No, did I become 4 ever? Uh, Remember, going back to I equal to 3, when I becomes 3 here, we ask for the grade, and the grade goes into grade 3. And what grade went into grade 3? -1.
Mm-hmm.
Okay. After that, there's no I plus plus. We went up to the top. The grade 3 is compared to -1, and it is, this condition is false. Loop ends. So what is I?
3.
3. So, but grade 3 is -1. But we don't care about that. But this number of data we have stored is 3, and that is equal to what I has. Do you see that? Right? The number I right now has a 3, and that is also same as the number of data we have stored. The number of data is 3. Three, three numbers have been stored in the array. So when the loop finishes, whatever the I is, that is equal to the count of the data. So I can copy this I to the count. That's what I'm going to do next. But before I go to that step, let me explain something else. I have this I less than 99 as part of the loop control because we cannot let the I go beyond the size of the array. Size of the array is 100, so subscript can go up to 99. And since we are storing -1 also, the largest number of data we can store is 99. That's why I'm saying I less than 99. In other words, subscript value can go up to 98, 0 to 98, because the 99th element is going to have the -1. So actual number of data we can store here is 98. Because the -1 is also getting stored. So um, if the user has more than 98 data, more than 99 data, then we cannot handle, right? So we have to set the limit somewhere. So that's why it's set to 100. And if any user is trying to use it for more than 98 data, the program has to quit and give the user a message that we cannot handle more than 98 data. So how do I decide that? Well, if the grade I became -1 and loop ended that way, that means the number of data was within the limit. If the number of data goes beyond the limit, then grade I is never becoming -1. Instead, I become 99. If I becomes 99, we want to stop everything. We cannot handle 99 data. So when the loop ends, there are 2 ways the loop can end. Grade I becoming equal to -1. That is the way we want to, that's the way we like it. If it ends that way, then everything is fine. If it doesn't end that way, then it ends by I getting equal to 99. So if that happens, we have to stop the whole process, whole program, and put a message on the screen. And that's what I'm doing next. If I equal to 99 when the loop ends, then see out too many data, only up to 100 data can be entered. Actually 99 data can be entered. And then return 0. Return 0 is how you terminate the program. Anytime return 0 is executed, your main program terminates. That's the return statement for your main function. Main is also a function, and if it is supposed to return, that means terminate. Okay, that is there to make sure our data doesn't go beyond the size of the array. That's why that is there. Now I'm saying count equal to I, because I explained a minute ago that the I equal to the count of data. So if I copy that into count, do I need to copy that into count? Can I just use the I in the remaining program as if I is the size of the array that's filled in with the data? Yes, but if you copy it into count, a reader can understand what's going on. The I has the correct count, so you're copying into the variable count so that you have the count correct. All right, so now all I need to do in this particular programming question is to find the maximum grade. So I call the find max, pass the grade array, and the size of the array. Size of the array means the number of elements that are filled in, that the count has that. So I pass that number so that this function will only look at that many data, the data that are filled into the array, and find the largest among those. So this function doesn't walk beyond the actual part of the array that's filled in with the data. This function will return the largest value. And so find max, this function call brings back the largest value found, and I copy that into largest, and then I print it. And that's all the program is. So the main thing here is the Sentinel control loop. You have to set it up this way. You're using Sentinel control loop to get data stored in an array. So you have to set the I to 0 somewhere separately. If you write grade 0 here, that may become a problem because you're writing grade I here. So it'll be better if you set the I to 0 separately and then grade I here. That means you're storing value in the grade I, and that same grade I is being compared to -1. So the first data has to, you have to get the first data before the loop begins so that this condition can be checked for the loop to start. So the condition is checked, the loop starts, and after that, you get all the other data. So this loop is only getting the data stored in the array. And also, you're keeping track of the count. I has the count. And then you copy that count into count and then proceed to process only that many data, the data that is filled in. Now, this is how you're going to do the project also. In the project, you need to allow up to 15 data, and the actual data are less than that. So you had to do this, you had to keep track of how many data are being stored and use that count for the rest of the process. Also, notice that if you need to get more than one data, more than one array filled, like in addition to grade I, you're going to, let's say, you're going to get 2 pieces of data from the user. You can do that here. You can write, let's say, other array is num. So num bracket I. All right. So if you write it this way, you're getting 2 numbers from user. One number goes into one array, the other number goes into the other array, and you're using only one Sentinel. You can do that. The user will enter -1 when he is done, but you only need to compare one of them to -1 to terminate the loop. And so in the project, you need to do that. You need to get 2 arrays filled up. So you can do it this way. It's that simple. You don't have to write 2 separate loops. You get both arrays at the same time. So user enters 2 numbers and they go into 2 arrays. And as long as the first array doesn't have -1, you keep going. Increase the I and ask for the next 2 data and get them into the 2 arrays. And the other thing is there is this one thing in the project that makes it a little bit more difficult, like thing is the wrong data, incorrect data are there, and you need to ignore them and only process the correct data. That part makes it a little more complicated, so I decided to remove that. The reason why I had that is because in reality, when you collect statistical data, it is a statistical analysis problem in this last project, in the project you're doing. But when in statistical problems, the data you collect is not always perfectly accurate. Some data are off the track, and you need to figure out which ones they are and not use them in the calculation. And that's the reality. So I wanted to be realistic, but it's, maybe it should be real for the professional programmer. For you, it should be a little bit easier. So I decided to delete that requirement. So basically, there are two lines of data that are inaccurate data, and so I'm asking you to delete them. You got the email message. I send you the details. You remove those and use only the remaining data. You still have to use two arrays to store the data. So the setup I've shown you on the screen right here. Kind of this is what you need to do to get the data stored in the two arrays. And after that, you have the size of the array that's filled in. Even though arrays have to be declared as size 15, you are actually counting how many data are stored in those arrays, and you're only processing that many data. So this feature that I have explained here is needed in that project. If you have any other question, after you get started, after you write whatever you can, you can bring up questions if you have trouble figuring out the rest. All right, I had some students in the office hour yesterday asking me to help them with the project, and I did. So that's how you do it. You should get help and do it. I have always said, I'm willing to help, and you need to do it yourself with help. But too many students didn't do that, and they decided to take others' program and submit that. Well, even though I knew that some of those are going on, what can I do? I didn't want to challenge them and get into a problem with them, so I ignored them, and look what happened. And most of those students who try to cheat in the assignments and projects ended up dropping out, because you can't keep doing that. If you start doing it, you're going to have to do that throughout the semester, because you're not learning anymore. And they figured out at one point it's not worth struggling, and they dropped out. Well, I hope the remaining students will learn the right way and complete the course. Anyway, so feel free to do the best you can first, and then bring up any question, any trouble you have. I even figured out error in programs for some students when they couldn't figure out where the problem was. I figured it out for them, and so I'm always willing to help. And so I have office hours tomorrow, and that's it for this week. After that, it will be Sunday. All right, anyway, your test is going to be on Monday, so we have to have all the discussions done by Wednesday, and that's why all the homework will have to be collected by Wednesday. Only the project I can extend to later. So I decided to extend the project to Friday, and I will make that change in the link today. All right. Next topic is section 6.6 is about searching and sorting arrays. This is our last topic, and so we are coming to the close of the course. Fortunately, we finished right in time. So let's finish this topic, searching an array. Searching is very common task. You know that when you go to a bank and you say, okay, I want to withdraw $100, then they have to enter your account number. When they enter the account number, the system, and press the enter key, the system searches the entire records to find your account number. and then it brings up the account information on the screen. And same thing anywhere you go, you go to the registrar's office and you want to drop a class or add a class, the first thing they need to do is find you in their system, and that means searching. The searching is almost everywhere. In any software, you have to have searching routine. So we need to understand how to write that. And writing the search is easy, nothing complicated. So I'm going to explain to you on the board. Um, and that is the recommended way for you. And students come up with their own versions, and there is always issue with those, or they're inefficient, something. But the one I'm going to show you will be the most efficient, the best way. And it is easy, the easiest way too. So I'm going to write it as a function search. So function search will receive an array. I'm going to make it float array, doesn't matter. You write it to match whatever the actual problem is. So search receives this array, and I have to receive the size. You always have to receive the size of the array whenever you are receiving array. And then I also receive a item to search for. So there'll be float item, I'll call it. I don't like long names, but it's really search item. That's what that is. Okay, and I'm not going to compare every element of the array to the item until I find a match. And if it matches, if I find a match, then I return the location. The location is the subscript value. That's all I need. I return the subscript value. Okay, so inside the function, I just need to say, I need to declare the variable. So I need a subscript variable, int I. I start that at 0. And I don't see any need for anything else. So I'm going to say, so what do I need to do? Take AI and see if it matches item, right? Compare it to item. If AI is not equal to item, then I have to go to the next element in the array and compare that to the item. So right now I is 0, I'm comparing A0 to the item. If it is equal to item or not is the question. So if it is equal, we're done. So if it is not equal, so I'm going to say if it is not equal to item, AI not equal to item, the writing went a little crooked, so let me write that again. If AI is not equal to item, then I need to increment the I, right? And but I need to keep doing it over and over. So therefore, it's not if, I need to say while. While they remain not equal, keep going, keep moving to the next. So while AI not equal to item, keep going to the next means I++, that's all. And that's it. That's going to search. While AI is not equal to the item we are searching for, increment the I and repeat. Repeat means what? Compare the next one now to the item. And if it is not equal, increase the I. That means compare the next one. So it'll increase the I and do this comparison. Increase the I, do this comparison. So if the item is in the list, then the loop will end with I being the location of the item. I is the subscript value we need. So I has the answer when the loop ends. But you had to allow the possibility that the item may not be in the list. Okay, so if the item is not in the list, what will happen? It'll keep going. This loop will keep going, searching through the entire array. So, so let me use an example array to explain that. Let's say my array has these numbers, 15, 25, and 30, 0, 1, 2 are the subscript, and that's all I have in this array. And so the array size is set to be 3. This size is going to be 3 when I pass this array to this function. I have to pass the size as 3. So when the I is 0, so let's say the search item is equal to 40. Then it compares the 40 to the, when I is 0, compares it to this, and they're not matching. So I becomes 1, comparing this. They're not matching. I becomes 2, comparing to this. They're not matching. I becomes 3. When I becomes 3, I don't want to continue anymore, right? I don't have anything to compare. So when I becomes 3, my loop should end. So that's why I need to add another condition that says I less than size. I can, when the size is 3, I should go only up to 2. 0, 1, 2. 3 items are finished. So I should go up to size, and that's it. So what happens if the item is not there? When I is 0, they're not matching. I is 1, they're not matching. I is 2, they're not matching. I becomes 3, loop ends. So if there is no match, the loop ends with I equal to size. So therefore, after the loop, I need to see if I became equal to size. If that happened, that means the item is not in the list. Only then I will become equal to size, and the loop ends that way. So therefore, if this happens, I need to return some number that indicates that the item was not found. So I return to the main a -1. If the function, so the main program should know that if it receives a positive number back, that means the item was there. If it receives -1, that means item is not there. Okay, so else, that means if I is not equal to size, then that means the item was found. Only then I will be smaller than size, and the loop will end because AI became equal to item. When that happened, the I must be less than size. So if I became equal to size, return -1, otherwise return the I itself. I has the answer. That's how we finish that search function and close that. So this is your search function. So whenever you need to search any array, you can use this exact same thing. If you write the search, there are other ways to write the search routine, but if you write any other way, make sure it's going to work right, and also make sure it is the most efficient. It is going to be efficient. You don't want to do comparisons. See, the comparison is a lot more work for the system than arithmetic work. Comparison is more work. You will learn that, when you go to higher level classes, you will be learning efficiency and how to make your program efficient. And you will be learning what things take more effort on the part of computer and makes the program inefficient and all that. See, these two courses, Computer Science 1 and 2, which is 271 and 272, are the courses where you actually learn foundation for the entire computer science. After that, most of the things you learn is about how to improve your program, how to make it efficient, and also techniques for writing programs, things like that. So this foundation has to be solid to be able to do the rest of the computer science. All right, so that's all you need to do with the sword. If you write it any other way, make sure it works perfectly and it is efficient and not too sloppy. The next thing is to understand sorting. Searching this is all you need to learn about search. And I just wrote the function for you. The function is not there in your book, but this function I wrote on the board is good for any programming task. All right, so let's go to the sorting. Sorting means arranging in order. Sometimes you want to arrange them in increasing order. The entire array you want to rearrange to get increasing order. Sometimes you want to rearrange to decreasing order. So we're going to see how to write a function that will receive an array and it'll rearrange the original array. You know that anytime function is passed to an function, array is passed to a function, the function gets access to the original array. It is not getting a copy. So this function sort will rearrange your original array to increasing order or decreasing order, whichever you like. And we're going to first learn the technique. And there are two techniques that are designed to be learned in this course: selection sort and bubble sort. But between the two, the bubble sort is the more efficient one. The selection sort is less efficient, takes more effort on the part of computer. So it's very rarely used. Bubble sort is the one that's commonly used. Programmers use bubble sort anytime they need to sort. And you'll be learning other techniques in high level classes, but bubble sort is still the most popular one. So therefore, I'm going to explain the bubble sort. It's not explained in the book, unfortunately, because it's left as an exercise. It's explained, the technique is explained, but the book doesn't provide the program. But what I'm going to do is I'm going to write most of the program. I'm going to leave only a little bit for you to figure out as part of the homework. But I'm going to write pretty much the entire program with very little detail left out. First, we'll discuss the technique. The technique is going to be explained using this example, an array of size 10. And I have some numbers stored in them. And these numbers have to be rearranged to increasing order. So our goal is to get increasing order, which means when our program is finished, when the function is finished executing, it's going to have this entire array rearranged to have this force, the smallest number first and largest number 41 at the end. All numbers are arranged. This is what we want to have. So how do we achieve that? And in the bubble sort technique, what you do is you compare each element to the next element only. I mean, if you have to compare with all of them, that's a lot of work. But this technique allows you to compare each element to only one number, which is the next element. And if those two are in order, you don't do anything. If those two are not in order, swap them. That's it. That's the technique. Just swap them. With that idea, if you do the entire array, you're going to achieve something. In one step, you're going to achieve something. I'm going to shorten that array on my board because we don't have to work with all 10 of them, but I'm going to shorten it to 3, 4, 5, 6. I'm going to use a size 6 to simplify matters. That's a little bit too many. So I'm going to work with 18, 22, 8, 41, 10, and 4. We'll just work with these. And what we want to do is we want to put them in increasing order. So bubble sort technique is to do this. Compare each element to the next. 18 and 22, are they in order? If they are in order, you don't do anything. These are in order, right? The order we want is increasing order, and they are in order. So you don't do anything. 18 stays there, 22 stays there. Next, you compare the 22 and 8. You just walk through the entire array, do the same thing. Compare 22 and 8. Are they in order? Are they in the desired order?
No.
No. So we need to swap, right? So swap, then 8 goes here, 22 goes here. Now compare the 22 and 41. Are they in order?
Yes.
Yes. So no swapping. 22 and 41 stay where they are. Next, compare the 41 and 10. They're not in order. So that means we need to swap. So we swap 10 and 41. And so we get 10 here, 41 here. Now compare the 41 and 4. Do we swap or not?
Swap.
Yes.
Yes. So we swap now, and that gives you 4 here and 41 here. Can you see that we have achieved something? What have we achieved? Anybody?
We have the largest one all the way on the right.
Right. The largest one has moved to place where it belongs. Right. The largest one belongs to the last entry, and it's there. So this idea of just swapping when they're not in order moves the largest one to the top. That's why this is called bubble sort. Everything bubble up to the top. Okay, now basically we are done with the 41. So what we will do is we will do the same process all over again. The next largest 22 will move to the second position if I do it again. After that, I need to cut off the size of the array by 2 and do the same thing. Cut off the size means I don't have to go all the way because the 41 is already in place. I don't need to compare that to anything, right? So after the first round, shorten the array by 1 for the second round, and then shorten by another 1 for the third round. That way you're making it more efficient and only comparing what you need. So how many times do you need to do this repeatedly? You're basically repeating the same process, comparing each one to the next. And if they're not in order, swap. That's all you're doing. And if you repeat that, if there are 10 elements in the array, I need to repeat only 9 times because if 9 elements are in place, then the 10th has to be in place. There's no place else, right? So you need to repeat the process 9 times, 1 less than the size of the array. All right, so let's see how to write it. Basically, I need to do this. If the I subscript value goes from 0, here it's 0, 1, all the way to, if my array ends at 4, then when I compare 10 and 4, that's my last comparison I need to do, right? I don't need to, there's nothing else to compare the 4 to. So therefore, I subscript value goes from 0, 1, 2, 3, 4. When the subscript is 4, fourth item and the fifth item will be compared. So in other words, the size of the array in this example here is 6. And the size of the array is 6, the subscript value goes up to 4 for the comparison purposes, right? When subscript value is 4, I'm comparing the fourth to the fifth, and that's the end of it. So therefore, I need to say for, let's move this up a little bit. Okay, so I need to say for I going from 0 to I less than size minus 1. I less than size minus 1 because if the size is 6, I goes up to 4. So that's why I'm writing, if the size here is 6, right? So the size is 6, the subscript values go up to 5, but my I needs to go up to 4. So 2 less than 6. That's why I less than size minus 1 means I goes up to 2 less than size. Okay, for all those i's, I plus plus, all I need to do is compare ai, each element, to next element, ai plus 1. So if ai, the order we need here is increasing order. So the strategy in this method is to compare each item to the next to see if they are in increasing order, because the desired order is increasing order. If they're not in increasing order, we swap. So what should be the inequality? If ai is less than ai plus 1, then we don't need to do anything, right? Only if ai is not less than ai plus 1, I need to swap. Agreed? So if ai is, what do I write? Greater or less?
Greater.
Greater.
Right, greater than ai plus 1. If ai is less than ai plus 1, I don't need to do anything. If it is greater, then I need to swap. So how do I swap? We know how to swap, right? You need a temporary variable b. So I declare int b, and then I copy one of them into b temporarily. This is the same swap we have been doing right from the chapter 1. And then copy into ai plus 1. And then what's the final step? Anybody? to swap two elements, if this is AI, I plus 1, we use a temporary storage and copy this into this first, and then this into this, finally this into this, right? That's what I'm doing. I copied AI into B, then AI plus 1, this into this, and finally what?
B into AI plus 1.
B into AI plus 1, very good. And that finishes the swapping. All right, this is it. This will do what? This will achieve, this is only doing one time. One time I'm comparing each element to the next, and when they are not in order, swapping. Comparing next to the next and swapping. This only achieves one thing, moves the largest to the top, right? Now, to get the next one to move, I have to repeat the same process again to move the next largest to a place. Okay, what does that mean? Anybody? What do I need to do? The program is not complete. This is only doing one step of the whole process. It's moving the largest number. It has moved the largest number to place. Now I need to say, repeat this. How do I do that? Another for loop. Another for loop that's going to say, repeat this over and over, but how many times? One less than the size of the array. Remember, if there are 10 elements, I need to repeat 9 times, then the 9 elements will be in place, which forces the 10th element to be in place. So therefore, I need to say for j going from 1 to, I don't need to go from 0 because this is only a counter that says repeat this so many times. So that's not subscript. The I is subscript, so it has to start at 0. J is not subscript. So j going from 1 to j less than size. If the size is 10, I need to go 9 times. So j less than size, j plus plus. That's it. I need to put that loop, and all of this will be inside the loop. So basically, this whole process of comparing and swapping is being repeated over and over. Now, the way I have written it, only thing that's not done is reducing the size of the array each time. See, it says when j is 1, I going from 0 to size minus 1. I'm doing the whole thing. So comparing every item to the next, all the way to the 41. And then j becomes 2, I'm repeating the process, but this time again, I go from 0 to size minus 1. That means what? I'm comparing all the items. I'm comparing the last item to 41, which I don't need to do. 41 is already in place. I don't need to compare that to anything, but I am comparing. So I'm wasting some effort here. I'm doing unnecessary work. And so after the second pass through the loop, the 22 would have moved to the top, right? So now when the 22 is in place here, the 22 should be avoided, and your array should be cut off right here, and avoid comparing anything to 22, and avoid comparing 22 and 41. No need to compare 22 and 41. They are in place, right? So that's the part I didn't do here. Each time this loop is repeated, I need to cut off the size of the array by 1. And that's the only part I'm leaving for you to figure out. It's a very simple change you need to make. You don't even need to bring in another variable, introduce any other variable or any other counting, nothing. A very simple adjustment you can, by doing very simple adjustment to this program, you can make it go down one size, make the size go down by 1 each time. And that's the part I'm leaving behind for you to figure out for the homework. This is same question is there in the homework, and it's asking you to write the bubble sort as a function, and then use that function to write a main program. All right, the main program part I can explain. Only thing you need, you have the function right here, the body of the function. You need to write the header. And the main program, suppose that I need to sort an array, then I do this. Int C bracket 5 equal to, I'm just making it an example, 25, 75, 85, 89, making 5 numbers, 45, 92. Okay, I need to sort this array. So what do? I call that function, the function name is bubble sort. So call the bubble sort function and pass. What other things I need to pass? Anybody?
C5.
Just see. When you
Oh,
pass
C,
an array,
yeah.
you only pass the name, no size. But the size has to be separately passed. Comma, 5. Size of the array is 5. So in this function header, it'll be void type bubble sort and int or float, whatever it is. A is the name we are using within this function, and the size, int size, both have to be received. The size has to be received separately. Array name is A. The C is being passed into A, and 5 is passed into the size, and semicolon right there. And this function is not going to bring back anything. It's going to rearrange the array. That's all this function call. Just make that call. It'll go there, and it'll end up rearranging the entire array to increasing order. And when you come back, the array has been sorted. Array has been arranged. So if you need to write out the array, then for int I going from 0 to I less than 5, I plus plus, you just see out CI with an E and DL, so that it'll be written one per line. You're writing the entire array using this loop. And so now the array is going to be in order. And that's it. Now, quick question. If I wanted to write the bubble sort function that will rearrange the array to decreasing order, what change do I have to make in this program, in this function bubble sort?
It has to be less than instead of greater than.
Right, this inequality, AI greater than AI plus 1 will change to AI less than AI plus 1. That's all. Everything else is the same. Because now our desired order is decreasing. So if they're not in decreasing order, swap them. That's all I need to say. All right, so that finishes the entire course. You're done. You need to do this homework. The last homework that was 21 is posted there. And then on Wednesday, we can go over all of these homework problems. And also, I will take questions on the review that's posted on Blackboard. I hope you have been working on that. Bring up questions on that on Wednesday, and then you'll be set for the test on Monday. So Monday is the third test. Your final exam is the following week. Monday or Wednesday, I don't know. I have to tell you that later. But it is on the following week, Monday or Wednesday. But next Monday, the third exam day, is the last day of classes. We are not going to meet after that until final exam. Okay, so I'll let you know when the final exam is, either on Wednesday or Monday. All right, enjoy the rest of the day. I will see you on Wednesday.
Professor, I have one question.
Sure.
What is the J in the for loop? What does that stand for?
Oh, the J is, see, the inner for loop is comparing each item, and when they're not in order, it's swapping, right?
Mm-hmm.
Then I need to say, repeat this whole thing, repeat this entire process of swapping, comparing and swapping over and over, one less than the size of the array, right?
Mm-hmm.
Times, repeat it. So that's what this loop is saying. For, I don't have to call it J, you can call it K if you want. But, all right, just a name, just a counter variable
okay.
that goes from 1 to 1 less than size. j plus plus, incrementing by 1. So it basically says repeat this process 1 less than size of the array times.